Good afternoon, one and all. Today we are having an important online program on metal filtration. In fact, we have been trying with the Sivakumar for the last 6 months to fix for this program. And thank you for him to being consenting to deliver a program for Chennai chapter number one. Today is a very unique filtration. It's always a question of to be or not to be for a foundryman because it's at cost to the mold. So whether to have it or not, that is how today's program is gaining momentum. So I now leave the floor to Mr. Sivakumar. Before that, requesting Siddharth to introduce Mr. Sivakumar to the forum, please. Thank you.
Thank you, Secretary sir. Uh, from the introduction or welcome address by a past chairman, I think it's very evident that Mr. Sivakumar is a very, very busy person. And I thank him again for his time and effort for his presentation. To just give a few words about our presenter, he is a very, very sound individual with almost 36 years of progressive experience in engineering manufacturing organizations, from hardcore manufacturing, work for Lakshmi Pattern Works, Sivananda Steels Limited, Lakshmi Machine Works Limited, Bratken India Private Limited, which is formerly known as Larsen and Turbo, PSG Foundry, Amex Alloys Private Limited, and Pitti Castings. He is currently serving at Pitti Castings right now. He is the plant head at Pitti Castings Private Limited, Hyderabad. He has been awarded as Indian Foundryman of the Year 2015 at national level by Institute of Indian Foundrymen. He has widely traveled to various countries like Germany, Italy, Japan, Jordan, Hong Kong, and has worked with multiple customers, so he has a well-rounded global knowledge. His academics include Diploma in Mechanical Engineering in 1986 at Bhakta Vatshalam Polytechnic, Kanjipuram. His BE degree in Coimbatore Institute of Technology, Coimbatore in 1998. He has continuously upgraded qualifications in the field of management and non-destructive testing, ASNT level 2 in radiography, ultrasonic, magnetic particle and dye penetrant test. He hasn't stopped his thirst for knowledge. He is currently pursuing his doctorate in management as well. His professional associations would include being an active member of Indian Foundry Association and IIF Southern Region, and a member of Technical Committee of IIF Coimbatore Chapter, a guest faculty to Premier Management Institutes. He has also been a member of in Board of Studies for Karpagam University, Coimbatore, PSG IIM Coimbatore, PSG Polytechnic Coimbatore. He is also a member in the Indian Institute of Foundrymen and a member under production and manufacturing sector to contribute expertise in development of instructional materials of course curricula under craftsman training scheme at National Instructional Media Institute NIMI Chennai, continuously associated with educational institutes for upgradation of students knowledge base with good industrial exposure. So from just these words, I am sure that we all should be very happy to have a very well-rounded professional who's in the manufacturing as well as the academics. So please, please make 100% use of this presentation. And before I hand over to Mr. Sivakumar, I would like to ask all of you to please mute yourself so that no disturbance can be found during the presentation. Thank you, sir. Over to you.
Yeah, thank you, Mr. Siddharth. Thank you, Mr. Saktivel, for the fantastic opportunity to interact with. Always, it is pleasure to interact with the Foundry team. So whenever we meet in any occasion, our age comes down by 20 or 10 to 20 years when we discuss with the Foundry team. So that is a vibrant wavelength between them. So let me take you through a small interaction session regarding metal filtration. It is purely based on my experience and some of the points I dealt during my various associations and assignments. Metal filtration basics and techniques. Yeah, as rightly said by Mr. Saktivel, Always it's a question of whether should we filter the metal. Many people says when we use the filter, it filters out our profit in the foundry business. So again, it's a debatable subject. So with all vigorous in the subject, I'm one of the person successfully implemented or ensured filtering of metal, and it improves the profitability. Since I dealt with the majority of my career, I dealt with the medium and bigger size castings. It has helped in a bigger way. So let me ask or raise the question: what is filtration, and why filtration is important for any hot metal? So whenever the metal enters the mold, either the metal carries the impurity, or it takes away the impurities from the runner bar, whatever it is, when it's flowing through the running system. So depends on the casting quality requirement, how impact it, what is the impact the impurities create to the casting. That has to be properly understood, and proper corrective measure has to be implemented. One of the effective method is to implement the filters in the right manner, in the right location, in the right place in the running system, so that it really helps us and it won't create any undue difficulties to the casting. Before we go into the actual foundry filters, let us go through some basics. So what is the filtration? Filtration is a process of inline metal treatment. Yes, it's a kind of a treatment, metal treatment, that takes place before the liquid metal is cast. That meaning, before the liquid metal enters into the casting cavity. So it prevents inclusions such as slag, dross, sand particles, etc. from entering the casting cavity. What one catch is here: whatever the type of filter you use, it broadly filters the slag, dross, everything, but the liquid slag which comes from metal or comes from the ladle, it tries to enter, and the filtration effectiveness of the filtration of liquid slag is not that much effective compared to the filtering other inclusions. So meaning, as clean as the metal, the filter is more effective. So it is known filters are installed in the gating system to retain exogenous, endogenous inclusions such as slag, foam, and other volatile materials which comes from the melt flow. Depending on the purpose, filter materials used like zirconium silicate, zirconium oxide, silicon carbide, and molite, etc. So filters were originally introduced to prevent non-metallic inclusion in the liquid metal. When the concept of filtration evolved in the foundry industry, maybe 10 years or 20 years back, original intention was to filter out the non-metallic inclusions. Later on, there has been a lot of research has been evolved in the filter manufacturing industry, and it has, while this still their main function, they are also used to control the velocity of the molten metal. When the metal enters in the running system, up to the point of filter, it can be a turbulent flow, but once it crosses the filter, I think somebody has to mute, some noise is coming. Shaktil sir?
Check. Sir, please all requested to mute your mics, please. Microphone as well as video. Yes, sir, you can start, sir.
Yes. So when the metal crosses through the filters, what are all the turbulence it creates in the running system? Once it crosses, it is becoming a laminar flow. So it is really helpful to uh, maintain or sustain the velocity of the molten metal. Let us again just to enter into the concept of filtration, how the filtration happens. So in the right side, just I mentioned some pictures in the top right corner. It is a simple concept of filtering the water. So how do we do the ancient days? Now any lot of filtration mechanism has come, aquaguard, whatever you call it as. So in the earlier stages, it is basic things. Any funnel will be filled with filter paper, then bubbles, kurangal and so on. Above that, coarser sand, and a upper layer will be a finer sand. So when the water is poured over the fine sand, so layer by layer, it is getting filtered. When you get the water at the bottommost mouthpiece, so it is fully filtered water, which can be directly used to drink. That is the concept of filtering any liquid. So the bottom of this, just to see the difference of water without filtration and water with which is filtered. So that's how the metal will be. The without filtered, unfiltered metal will have all its impurities, which is it out all the unwanted things. So again, it talks about filtration of water. Just to talk about the basics of filtration. So when the sand particles are next to one another, each other, pumps tiny spaces between them. Water can pass slowly through these tiny spaces. Dirt and impurities get trapped in this, so that the purest water comes out as an output of this filtration process, and it's used for domestic purpose. So when it comes to metal filtration, it separates solid particles and impurities from any fluid with the help of filter medium. Here is our filter. So this is what I was talking about. When the metal enters in the running system just before the filter, it was turbulent. Once it processed through the filter, it has become laminar flow. It won't affect the metal and it won't erode any sand or any coating from the running system. This is one of the additional biggest advantage of introducing the filters in the running system. Yes, we know it is a cost burden to foundries, but if you see the overall effectiveness, we have to. So it's a filtration is a process, either a physical or biological or chemical operation. The filter allows the fluid to pass through but hold the solid particles and impurities. So let us move on to the type of filters which are available in the industry and which are being used in many foundries, whether it is a small casting manufacturer or a medium casting manufacturer or a bigger casting. It is iron or steel or non-metallic, non-ferrous like aluminum. So there are cloth filters, ceramic foam filters, which are predominantly used in many foundries. Ceramic cellular filter or extrusion filter, or you call it as straight hole filters. Hypercast filters is nothing but the same straight hole filter with a high density material packed in that. And the last one is hybrid filters. Yeah, let us go one by one. And what is that? What are all the salient features? Let us deliberate. Cloth filters. So these are all made of oven refractory glass. It is very thin in very thin in layer. Although they reduce turbulence. Yes, obviously it will reduce the turbulence. They have very low filtering efficiency because of the small open area, which acts as a severe choke in the running system. The thickness of the filter is very low, and that metal bearing area is very less, and hence the effectiveness of this filter is very limited compared to other filters. It doesn't mean that it is not usable. Yes, compared to other filters, it is less, and based on the space and other constraints, practical constraints in the mold or pattern, we can decide on this. Collection of hygroscopic materials or condensation can lead to fabric plugging, loss of efficiency, and pressure losses. These are all the difficulties or constraints of limitations of this type of filter. Let us move on to the ceramic foam filter. We call it as CFF. This is the filter predominantly used in many foundries with various sizes, various shapes. Are most effective and efficient metal filters. They have an open pore reticulated structure with a very high volume of porosity over 90%. It has very high surface area to trap the inclusions, and the biggest advantage is that honeycomb structure which is created in the foam filter. It doesn't allow the any impurities to pass, but in this also any liquid slag it bound to cross. The metal takes a tartarus path through the filter, affecting the removal of very small inclusions. So, being the honeycomb structure, once when it metal enters the end one side of the filter, by the time it comes out, it has to travel through a uh, very difficult path. So, in that, all the impurities are being filtered. That is one of the main reason for success of these ceramic foam filters. By attraction and absorption to the internal ceramic pore surfaces, the filtration happens. Passing liquid metal through the ceramic foam filter reduces impurities, including non-metallic inclusions. Whether it is a sand or a ceramic material or coating material, whatever it is being perfectly filtered, and it is not allowing the impurities to enter into the mold. It is very much useful for getting the finished product without any impurities. It is one of the major advantage. So in the foam filter itself, we have three varieties. Depends on the application, depends on the material which we are going to use. These varieties are being used in foundries. Alumina ceramic foam filters, silicon carbide foam filter, which is predominantly used in many foundries, and zirconia foam filter. It is almost white in color. Silicon carbide filter. It is a light gray and dark gray in color. Zirconia foam filter, it is pale yellow. So out of these three, silicon carbide is being predominantly used because of its versatile advantages like effectiveness of the filtration and easy to use, cost effective compared to these three. The next one, we move on to ceramic cellular filters. It is again extrusion filter or straight roll filters, what we call. It has a square section as well as a circular section. Nowadays, any section you want, there are depends on the area available in the running system. It's being manufactured. Since the ceramic walls are thin, it can have only up to 78% of open area to filter, whereas our foam filter has more than 90% of the area. It's commonly used in aluminum castings and where the small castings are being manufactured and high pressure molding line. The next category is the hypercast filters. It is out of among all the filters, hypercast filters are having very higher capacity space, so it will be helpful to accommodate filters, especially other filters. Because of this higher capacity and less filters, obviously the cost of filtration is comparatively less compared to other filters. The critical castings in many found. Hybrid solution for filtration needs a bigger castings. Can be used for all types of bigger casting, irrespective of the grades, whether it is steel, whether it is ductile, whether it's a grain. If it is a complex casting, yes, best solution is a hybrid or a dual layer filters. It has a high temperature withstanding strength and good performance. Yeah. So so far we covered the types of filters which being commonly used and with respect to small or medium or bigger size castings. So let us move on to application methods of filters. So each and every foundry has their own style of running system. It differs from foundry to foundry, and we can say it is a secret of that foundry. So depends on the space availability and comfort of the operating team. These are all the methods being used to accommodate the filter in the running system. It's horizontal, vertical, single filter and multiple filter with a different size of size also being used. Depends on the space and the filtration capacity. A round filter method. So and there are other customized design methods. I have few pictures so that the team will have a idea how it is being implemented in other foundries, and it may be useful to adopt in your foundry as well.
Yes, sir. Yes, sir.
So
Yes, sir.
these are all the application methods. I have some pictorial views so that everybody can understand the concept and may be useful to adopt or use in your respective foundries. It's a simple horizontal type of filter. We can use a single or a double filter, depends on the filtration capacity and liquid metal requirement. So filter the metal entry is given from the top to the filter, and the filter metal is filtered and it goes to the bottom. From there we take a runner bar and it's being sent to or connected to the casting through a ingate or a ceramic ingate or a normal sand ingate. This is one of the typical method being used in many foundries, I hope. When it comes to a vertical method, the design of the filtration mechanism is very crucial because it should have a proper bearing, filter bearing locations on all 3 or 4 sides. So the biggest advantage is it carries maximum, it allows maximum space to filter, and one of the disadvantage compared to the horizontal, uh, uh, only 3 sides we are able to give the filter bearing area, because in the cope again we need to have a print, and when we close it bound to have any minor crashes, and hence normally we don't give any sprint over the top mold or cope mold. But nevertheless it's being used effectively in many medium sized foundries because it gives effective filtration, and that inlet and outlet is being designed in such a way that it accommodates perfect metal flow, and when it goes out of the filters on both sides or 3 sides, 4 sides, it depends on the casting design and running system design based on the liquid metal capacity. So when it goes out from the filter, the entire metal is being made smooth, and only laminar flow, it goes through a laminar flow. It's again a single filter application. Again, absolutely, it depends on the metal, liquid metal capacity or casting weight with the running system which is being decided. It's again metal enter in the top, filters through the filter through gravity, goes to the bottom, and from there it is taken out and connected to the casting or sent to the casting cavity. Yeah, next one is one interesting method is multi-filter application. So one cassette type arrangement we make, we use 2 or 3 filters. Uh, I have a good experience for these. So one of the component we used 3 filters in a row, 4 filters in a row. But we found after machining, we filter broken particles in the casting. Then when we discussed with one of the filter expert, he said it is not advisable to have 4 filters. Then we converted into 3 filter in the cassette. So post modification, we didn't have that problem at all. So when we go for a multi-filter concept, it is advisable to go with the maximum of normally go with the 2 filters in a row. If it calls for additional, let us go with the 2 cassettes like that. We have some pictures to demonstrate this additional multi-cassette arrangement. So it is better to have a series of filters in a row, but restrict the number of filters. It is between 2 to 3 maximum. Yes, this is the one which I talked about. So if number of filters, it is required to have more than 2, 3, or 4. It is better to have 2 cassettes like this. In this, one of the thing what just a minute. Yes. So one of the interesting thing is we have a bigger size filters, 2 filters, and a smaller size filters on both ends. Depends on the space on the print or space on the match plate. We can design like this also. We have successfully implemented this design. Various size, multiple filters in a row. It is, I can say, it is a hybrid solution for bigger casting, bigger size casting, and we came out of the issue of filter breakage in a bigger way. After we implemented this, yes, that filter breakage issue is totally eliminated. Once the filter breaks, again the casting gone. Already we are spending 1 rupee, 1.5 rupee per kg of casting for introduction of filters. Because of spending more, and if you are losing casting, it is purely lack of proper engineering knowledge. Once we think with multiple options like this, we can find a solution to avoid any filter breakage. It is a typical round filter application. It's in many machine molding lines. It's being used as a call pour, direct pour method, and particularly wheel type castings, single call pour at the center with a minor in gates, or directly over the casting. It's being successfully implemented with a high level of yield. Only thing, we have to ensure that the filter floats when the pouring is over. Otherwise, it will create a choke in the neck, and it may affect the riser effectiveness or riser efficiency. When you see in many machine molding lines, one person after pouring, one person will put a rod in the riser, and then it will make him to float. That is very essential to avoid any neck choke. Some other customized design what we adopt. So bigger filters and smaller filters in a row to accommodate required number of filters as well as required number of in gates, depends on the casting, match plate space or print space. It's yet another customized design. So both ends we have metal inlet with horizontal deployment of filter. So additional ingots have been taken out and it's being connected to one of the housing what we produce successfully. I have some of the case studies with my experience, how the filter is, to what extent it is helping to filter out the inclusions. If it is not designed properly, it is not deployed properly, it creates a problem also. Some of the actual casting pictures post machining. So it is a silicon carbide filter is being used and it has broken and entered in the casting. Post machining, it's revealed like this and we lost the casting. So the kappa for this is modification of filter design and major reason was in a row we kept 4 and then it has created problem. Now we altered this and we came out of this particular issue. So some of the filter prints with the filter insert and I shown the pictures here. So if you take that top one, left top one, these gaps, it is not at all advisable. The filter print should be designed in such a way that the gap is as minimum as possible. The purpose of we are placing the filter is to filter out the unwanted things. When we create such gaps, the unwanted inclusions or non-metallic inclusions float through these and enters into the casting. Of course, 90% will be filtered out or 80% will be filtered out. We do not know that non-metallic inclusion where it will sit in the casting. If it comes in the machining area, then entire efforts is gone. Similarly here, yes, huge gap. When it comes here, yeah, we have a multiple size of filter. Again, this gap is a typical killer in the foundry. So this one is it is not talks about the gap. It is the filter design is perfect, and it's shown to just to say how multiple locations in the running system filter is being captured. Let's move on to the base of the non-metallic inclusions reduce, improves mechanical properties or non-metallic inclusions. It improves the process yield, reduces porosity in the metal, thus improving thus improving the quality of the metal. It lengthens it extends the tool life in post foundry operation, particularly in the machining. So if the sand comes in the machining surface, when the sand that inserts within a single cut, the insert life will go up. So certainly it improves the tool life in the machining operation. It gives the increased productivity, meaning whether it is if you take a ductile iron, when I introduce the filter, it filters out drastically the dross, which is a killer in post fettling operation. Till the dross is fully removed, our NDT team will not clear the casting. So normal fettling will take 8 hours and dross cleaning also, dross grinding also will take another 8 hours. So when we introduce a proper type of filter or a right category of filter, it filters out and it improves the productivity directly. So as I explained during the earlier slides, so it enables laminar flow and hence no erosion of sand in the running system. It reduces the risk on quality in any jobbing foundries. Jobbing foundry, the volume is limited, as you know. Even with that limited quantity, if you lose some castings because of the impurities, impact because of the inclusions, it is a big burden on foundries and it reduces the risk of quality. Increases, obviously, the final motto is to improve the customer satisfaction. Though filter is recommended, it has some limitations when we when we use the filters in the foundry. As of now, to my knowledge, proper testing or checking facility is very limited or only the manufacturer will have. But as an end user, we do not know how to test, or we don't have the facility how to test. We are just following, receiving the filters and using it. Only the visual check what we do, or to test or any crack is there. So again, that depends on person to person. So if any cracky filter is being placed in the running system, and again, it hurts the casting. Cost of filtration is a burden on product cost and impact competitiveness. When it goes to bigger casting, it, as I told you, it is 1 rupee or 1.5 rupee per kg of casting. But when you see the overall advantage, it is nullified. Selection of right type of filter needs good expertise. So many foundries, obviously, we depend on the filter manufacturers, and it has its own pluses and minuses. It is known to everybody. Any type of filter, it has limitations in filtering out the liquid slack. I have used straight hole filter, hypercast filter, and honeycomb filter. That is a foam filter. Liquid slag is not being filtered out. Marginal decrease in direct yield, that is pouring yield, because of addition of filter and in the running system. If you calculate the overall yield, there is a drastic increase. With that is number of castings poured, a number of metric tons poured, and number of metric tons sold out. We have a major advantage on that. Filter print design is highly customized, and it needs, again, expertise for a period to avoid any difficulties due to this filter design of the filter print, and to accommodate effective filters in the running system. Filters are to be fixed as close as to castings for best results. This point is very vital. This is a recommendation by many filter manufacturers. So when we practically design our running system, it may be difficult to adopt this particular technical point due to various practical difficulties like a double pin or core print, the space in the match blades. So again, it is subjective, and it varies case to case, and we should adopt as best solution for getting the effective filtration method. It is always advisable. It is my own experience. Always advisable to design our filtration system within 70 to 80% of the recommended capacity by the supplier, because suppliers or manufacturer always will give the range as 100 kilos to 130 kilos. If you design the system for 130 kilos, it depends on how clean is your metal, how clean is your running system, how clean is your mold, all those factors. So even a one casting, if you lose because of filter breakage, then you have to compensate with the 50 castings. So it is always advisable, and we started practicing it to design the system with maximum of 80% of the recommended capacity. And one of the interesting input I got from one senior senior foundryman from Bangalore. One of his assignment, they were continuously getting, even after using the filters, they were continuously getting non-metallic inclusions in the casting. So they listed out what are the probable causes, and they eliminated one by one. Finally, they came to understand the foam filter. There is a coating is being used in the foam filter. That proper quality of the coating is the root cause, and it was dissolving when the hot metal goes in, and it was settling in the casting surface, and opened out after machining, and they lost a huge lot. They lost huge lot. It is recommended or advised to advisable to use filters reputed organization. I'm doing any marketing, but I'm sharing my experience. Then criteria for the selection of the filters. Obviously, the material of the casting material to be poured. Quality requirement of the casting. If the casting calls for level 1 or NSD, some casting even we are pouring a casting which is it is 100% NS, non-significant effect. So we have to design our system with a high quality of filters, high level of filtration capacity to avoid any impurities in the casting. Flow rate and anticipated volume of the liquid metal which is going to be poured in the casting. So based on the volume, we'll decide number of filters and how it is to be oriented, whether it is vertical or horizontal or a multi-filter or arrangement or multi-size filter arrangement. Depends on the volume of the metal to be poured. It has to be designed in suitable way. Again, it varies to foundry to foundry. It's again alloys used in the metal to decide on a PPA requirement. That is 10 PPA with the coarser is okay, or very finer in the coarse is required. Again, casting volume. So I listed down some of the recent trends in the filtration industry or filter industry. So to cater the extensive demands or increasing demands of foundries, there are good research has been done by the filter manufacturers. These inputs are taken from one of the leading filter manufacturer website only. So optimized filter housing design, it gives 3 times the filtration area, tubular filters, cylindrical or tubular filter. It is again a zirconium filter and looks very impressive what type of research has been gone into it, and really it is helpful for the foundry industry. Ceramic pots, instead of keeping the filter in the our sand running system, there are ceramic pots available with male-female arrangements. So entire metal goes through the ceramic system so that there won't be any metal sand erosion or anything. So it's again high degree of filtration, and it is perfectly useful. It will be perfectly useful for super quality castings what we are producing. And filter housings. So there are 6 filters or 8 filters being used in a same housing. Again, it has thanks to the filter manufacturer's website. So, it is some housing type thing. Metal is being given in the center. It filters out entire thing, and it comes out outside, and from outside the mouth, it has been taken to the casting. So the biggest advantage of such designs, even for the bigger size casting, irrespective of the space available, it's being implemented successfully. It can be implemented successfully, and uh, quality of the casting can be enhanced in a very bigger way, much bigger way. So finally, I have a small video clipping. Uh, it is a casting wind turbine, 2 megawatts wind turbine casting. Casting weight is I think 12 tons or 13 tons, I forgot. So the velocity, the filter helps to reduce the velocity. I would like to demonstrate here. It is a practical example I have gone through, and I have poured this casting in my experience. See, up to the filter pots being used, up to the filter entry, the velocity is somewhere 1.6, even 2.5 meter per second. Once the filter enters, the metal enters and cross the filter, the coupler has become a blue. That is within 0.4 or 0.5 meter per second. This is a practical case. It's the best example how the filters helps to reduce the season out the metal entering in the casting to avoid any turbulence or any erosion during the metal flow to the casting. That's all from my side. If any questions, I'm ready to answer, or we can debate over that. Saktivel?
Yes, sir. The floor
Yeah.
is open. So anybody have any questions, please? So I presume there is no questions being raised.
Good.
Yeah. So Raj, you can start your vote of thanks, Raj.
Thank you, Shakti, sir. On behalf of IIF Chennai chapter, I would like to express our deepest gratitude and appreciation to everyone who made this webinar a great success. First and foremost, I'd like to thank Mr. Sivakumar, Planted Pitti Castings, who shared his valuable insights and expertise on the topic metal filtration. Your contributions have been invaluable in making this webinar an informative one for all. Sir, it's always been great pleasure to hear you. Either it's technical or motivational, you give your best. I would also like to thank and acknowledge the presence and participation of our esteemed fellow Foundrymen for joining us online and making this webinar a fruitful one. I look forward for your continued support in the upcoming days too. Thank you all once again.
Thank you, sir. Thank you one and all
Yeah.
for attending. Thank you. Thank you.
Thank you. Thank you.
We'll
Bye.
be in touch.
Thank you,
sir.
Sivakumar, sir.
Yeah, sure, Raj, sure, Sakti.
Thank you, sir. Thank you. Bye.
Thank you.